In this lesson, we're going to talk about the states of matter, and three major ones that you guys are familiar with, and maybe a fourth one that you're less familiar with, but it's actually the most common state of matter in the solar system and in the universe. We're not familiar with it here because there's not a lot of it on Earth, but stars are in the plasma state of matter. So let's start with our common states. We've got solid, and solid is exactly what it sounds like. The particles are arranged in such a way that they cannot shift, which leads to a rigid, solid body that does not take on the shape of its container and has a definite volume and a definite shape. So it doesn't matter if I put this in a beaker or in a bowl, it's going to be that solid mass of particles and it's not ever going to change. Now, clearly I can beat on it and I can break it, but just moving it from one place to another does not change its shape, nor does it change its volume. And that's because those particles are fixed in position. They can't move. They can vibrate back and forth in place, but they jostle into one, they jostle into another, but they stay in their relative positions. Whereas in a liquid, those positions are not fixed. Now, the arrangement of the particles isn't fixed, but the closeness of the particles is. And what I mean by that is the particles are still all going to be piled up next to each other. It's just that they can shift around each other. So this particle that's right here might end up down here, but it can't really move away from the rest of the particles. And so when I put it in a container, they flow around to fill the container, the bottom of the container anyway. So if I had this much liquid in a container this big, and then I poured it into a container that was bigger around, it would still be the same amount of liquid. It would not take up more space, and so all those particles would flow around, and they would be less deep over here, right? Because they've got a bigger area to occupy, they can't go as high. So the solid, definite shape, definite volume. Whereas the liquid, no definite shape, but it does have a definite volume. And so just moving it from one container to another means its volume won't change, but its shape will. It will take on the shape of its container. Gases are different yet again. And gases have very low attractions between the particles. So here the attractions are so strong the particles can't even slip out of position. They're locked in. Here the attractions are strong enough to keep the particles together, but not strong enough to keep them from shifting. In gases, the attractions between the particles are so weak that even when the particles collide, all they do is bounce off of each other. And so I've got to have a closed container to hold a gas in, or the particles will all leak out. And so these particles are bouncing around pretty quickly in constant, random, fast motion. And so that means they're not all hanging out at the bottom. They are actually going to be bouncing all over the place. So that means no definite shape, just like a liquid has no definite shape. But since these particles have no requirement on being locked together, they can spread apart from each other. That also means no definite volume. And no definite volume means that the gas expands to fill its container. Expands to fill container. And so measuring the amount of gas you actually have depends on a lot of different things. Depends on the shape of your container, the pressure in your container. So if you're massing a gas, that gives you the number of particles, but the volume, the pressure, those things can change. The last state of matter I want to talk about is plasma. Now, plasma is different than these three because in these three, all we're doing is we're messing with how the particles are arranged. In plasma, we actually mess with the particles themselves. And in plasma, this is an ionized gas. Now, all that means is it's got charged particles. In most matter is made of atoms. Atoms are made of protons and neutrons and electrons, and the protons and electrons are arranged together so that the overall charge is zero. The positive charges and the negative charges cancel out. In an ionized gas, or a plasma, that's no longer the case. The particles themselves actually break apart. And so this is a fluid, as in the particles can easily flow around. It behaves a lot like a gas, but it's got positive and negative parts to it. And so Sometimes you'll see this represented as broken particles. Sometimes you'll see it as pluses and minus particles floating around. But plasma occurs at super high temperatures. There's plasma in fluorescent light bulbs. The sun and all stars are in the plasma state. It's ionized gas. And so plasma is the fourth and most common state of matter in the universe, not all that common on Earth.